Hello, this time we're looking at energy changes as well as electron configuration and bonding. It's a GCSE past paper question, but the content is also useful for A-level students and BTEC students. The question details and format are on the screen now. Let's get started. Here's the question. This question is about sodium and chlorine. The diagram shows the positions of sodium and chlorine in the periodic table. State one difference and one similarity in the electronic structure of sodium and of chlorine. The horizontal rows in the periodic table are called periods. Elements in the same period have the same number of electron shells. Avoid the phrase same number of outer shells. All atoms only have one outer shell of electrons. Both sodium and chlorine are in period 3, so they have 3 electron shells. The vertical columns on the periodic table are called groups. We do not count the elements in the centre of the periodic table. These are the D block elements and have a more complicated electronic configuration. Sodium is in group 1 and chlorine is in group 7. Sodium atoms have 1 outer shell electron and chlorine atoms have 7 outer shell electrons. Here's the next part of the question. Sodium atoms react with chlorine atoms to produce sodium chloride, NaCl. Describe what happens when a sodium atom reacts with a chlorine atom. Write about electron transfer in your answer. The diagram shows how many electrons are in the outer shell for an atom of sodium and an atom of chlorine. Electron transfer takes place, making a sodium Na+ ion and a chloride Cl- ion. Both ions now have a full outer shell of electrons. Ions are shown in square brackets with the charge. An ionic bond is the attraction between the positive and negative ions. Let's address the question. Each sodium atom loses 1 electron, each chlorine atom gains 1 electron. Here's the final part of the question. The reaction between sodium and chlorine is an exothermic reaction. Complete the reaction profile for the reaction between sodium and chlorine. For an exothermic reaction, the reactants have more energy than the products. The difference in energy, or enthalpy, is referred to as delta H. This energy is released to the surroundings as heat. We have to put energy in to start the reaction by breaking chemical bonds. This energy is known as the activation energy, EA, and is shown on the diagram. After GCSE, you may go on to study enthalpy, the heat content stored within a chemical system. This is linked to the relative energy of reactants and products that is studied at GCSE. For an endothermic reaction, the reactants have less energy than the products. Activation energy is shown on the diagram, as well as enthalpy change, delta H. Delta H for an endothermic reaction is positive. In an endothermic reaction, the surroundings get colder. Thanks for watching. If you have any questions about the subject content or suggestions for the format of future videos, please just let me know. Take care and goodbye.